dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Warahmatullahi wabarakatuh. My students, particularly from trees, this is our class. So if you remember, we were in here, what we call periodic table. So we came across whole chapters of from trees. So we were in what we call a revision classes. So we are in this chapter, periodic table. So this is online classes, Amano online classes or e-learning classes. So if you remember, we came across introduction to periodic table. We came across what we call atom, structure of the atom, what we call isotopes, atomic number, mass number. So we came across these parts. So in this section, we want to discuss periodic table, say periods, again groups. We want to discuss these areas. So periodic table, first we have to define periodic table. So periodic table is a table. It's a table on number of cells with groups of similar properties and periods of essentials. So periodic table, this kind of periodic table is called a modern periodic table. So modern periodic table, it was developed by someone called Henry Moseley. So this is based on atomic number. If you consider here hydrogen is 1, next to hydrogen is helium. It is 2. Again 3 lithium, beryllium, boron, carbon. So this kind of periodic table based on an atomic number. And we came across atomic number. Atomic number is the number of protons. So we want to discuss this periodic table. So periodic table is divided as what? As groups of elements with similar properties and periods of essentials increase in atomic number. So two important things are here. So here we have what we call, here you can see period. Again we have here groups. So this periodic table, it contains groups and periods. So what are groups, what are periods? What are groups and what are periods? So groups are vertical columns of the, so first we have to before groups and periods, we have to classify. We have to divide periodic table into two main parts by considering the kind of elements. So this periodic table contains metals and non-metals. It contains what? Metals and non-metals. So here you can see this is the left-hand side of the periodic table, and this is the right-hand side of your periodic table. So these left-hand side elements are always metals. What about the right-hand side? The right-hand side we combine what we call non-metals. So if you consider, or this picture will give you an indication that metals are much more than non-metals in our periodic table. For example, if I write here, I can say around 75% of the elements, whole elements are metals. Here I can say 25% of total elements are what? Non-metals. So metals are much more than non-metals in our periodic table. They have a probability of 0.75. This may have a probability of 0.25. So at this time, metals, they have a properties. Again, non-metals, they have a properties. You see, the properties of metals and non-metals are always contrary, are always what? Opposite. So we shall consider. Here I have what? Some properties of metals and non-metals. For example, if you memorize some of these metal properties, you don't want to memorize this. For example, in the exam, we can ask you at least say mention or state, list any three, any four properties. For example, you have to memorize any four properties of metals. What about the non-metals? Non-metals are opposite of those metals. For example, most of the metals can conduct electricity. What about the non-metals? Most of the non-metals, they do not conduct electricity. But you can get a non-metal which can conduct electricity. You can get a non-metal or you combine a non-metal which can conduct electricity. But generally, non-metals do not conduct electricity. Why metals conduct electricity? We came across this one, our chapter electrolysis. So we said metals conduct electricity because of their free electrons. What about the non-metals? They do not contain what we call free electrons or delocalized electrons. That is, we are using most of metals. As I can say this one, not most of metals. I can say all metals conduct electricity. What about the non-metals? Non-metals, I can say, generally they do not conduct electricity. What about carbon? Carbon, or allotrope, call it graphite. Graphite, it can conduct electricity because it contains free electrons or delocalized electrons. So at this time we have some exceptions, but in general they do not conduct electricity. What about the most metals are shiny? Most of the metals are shiny. What about the non-metals? Non-metals are not shiny. So it is the opposite. They have a high densities. What we call metals, most of the metals have a high densities. For example, mercury, it doesn't have a high density because it is a liquid. But non-metals, most of them, they have a low density. What about melting point and boiling point? Melting temperature and boiling temperature in general. Metals, they have what we call high melting and boiling temperature. What about the non-metals? It is the opposite. They have low melting and boiling. Generally, they have low melting and boiling temperatures. Most of them exist as solids. You see, metals, they always exist as solids, or most of them, except mercury, which is liquid at room temperature. What about the non-metals? You can get some solids, one liquid, which is bromine, and the remaining are gases. They form what we call basic oxides. What about this one? It is the opposite. They form what we call acidic oxides, which means they form basic oxides, and these are acidic oxides. They form ionic compounds. Again, they do ionic compounds as well as covalent compounds. They are malleable and ductile. These are not malleable and ductile. So these are the properties of some metals and non-metals. Here we have a picture. So this is the periodic table. So this is the key. So for you to read this periodic table, here you have what? So this color indicates you non-metals. These are the metals, say metalloids and noble gases. So metals, say non-metals. These are light blue non-metals. What about metals? This is the yellow one. What about this green? This green is always close to the what we call zigzag line, the red zigzag line. So this red zigzag line element is close to this or nearer to this zigzag line are called metalloids, which means semi-metals or semi-non-metals. You see, they are metals or non-metals. But for example, here we have what we call germanium. Germanium, it is a metal, but it behaves like a metal. What about silicon? Silicon is a non-metal, but it behaves like a metal. Sometimes it slightly conducts electricity. But it's a non-metal. So this element is close or nearer to this zigzag line are called what we call metalloids or semi-metals or semi-non-metals. Noble gases. You see, noble gases in general they are under non-metals, but they have a different property about the other non-metals. So they have this gray color. Okay, keep going. A periodic table can be classified as periods and groups. So first we have to mention what we call period. So periods are the horizontal rows of the periodic table. So what is the horizontal row? I want to mention the horizontal row. So what is the horizontal row? So this is called horizontal line, and here is a horizontal line. So in between two horizontal lines, it is what we call row. This is a row. So how many horizontal lines you have in this periodic table? So we have how many rows? You see, this is hydrogen, for example. This is hydrogen. So this line is, here is helium. So I want to remove this part. So where can I put here? Okay, put it there. Okay. So this is helium. You see, this is helium. So hydrogen and helium are first row of our periodic table. Do we have another period? Yes, period 2 is lithium. It starts lithium, say beryllium, say beryllium. Again, here you have boron, say carbon, nitrogen, oxygen, fluorine, and neon. So this is row 2. You see, that was row 1, say row 2. This is row 3. Row 3 starts from sodium. This is magnesium. Here you have aluminum, say silicon, phosphorus, sulfur, say chlorine. Again, this is argon. This is argon. So how many rows we have here? That's row 1. This is row 2, say row 3. What about row 4? It starts from potassium. It's supposed to be what? Potassium. This is calcium. This is cadmium. So we can't continue because here is the transition metals. So this is period 4. This is period 3. So period 1, it contains around only 2 elements. Around 2 elements, say 2. What about period 2? It contains around 8. What about period 3? It is around 8. So this is 2, 8, 8. What about this one? Period 4. Period 4 is supposed to be 8, but here we have 10 elements. So it's supposed to be 18. It's supposed to be 18. Period 5, same principle with period 4. It is 18. The last 2 periods, lanthanides and actinides, they are around 32, say 32. So this model periodic table, it is, I can say 118. But at this time, the real periodic table is not 118. It's not 118, it is more than 118. It's close to 150 elements. 150 elements. The concept behind here is the period is, you see, our period is 2. Here is 3. So the number of elements are increasing down. And the number of elements are increasing down. Okay, so let us come to this point again. So the most important thing is what? Periods are horizontal rows of the periodic table. Horizontal rows of the periodic table. Horizontal rows of the periodic table. So in modern periodic table, how many periods we have? So we have around 7 periods. 7 periods. So that's the point. Consider this one. This is row 1, 2, 3, 4, 5, 6, 7. These are the rows or in our modern periodic table. So we have 7 periods. 7 periods. So groups. What are the groups? What are the groups? Groups are the vertical columns of the periodic table. So this is vertical line. Okay, consider so this is a vertical line. This is a vertical line. Okay, this is a vertical line. Again, this is another vertical line. So in between 2 vertical lines, there is what we call column. So this is a column, this is called a column. So how many columns we have in our modern periodic table? So we have 18 columns. 18 columns. We have 18 columns. But in our level or secondary level, we are not going to do transition metals. So ignore transition metals. Transition metals are 10 groups or 10 columns. So when you remove, so subtract 18 from 10. So the remaining part is what we call 8 groups. So we have 8 groups. So this is group 1. This is group 1. This is group 2. It's supposed to be 3, say 4, 5, 6, 7. Here you have 8. Here you have 8. So we have 8 groups. We have 8 groups. So our modern periodic table contains 8 groups, means 8 columns. So each column represents one group. Okay, consider this one. Consider this one. Consider this one. That's group 2. Say 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. So 8 means O. So this group is also called group O, or noble gases. So we have 8 groups. So we want to explain these groups. For example, we want to do group 1 and 2. Again, we shall see group 7 and 8. So these are non-metals, indicates you the properties of non-metals, and these two groups indicate you the properties of metals. You see, metals are always located the left-hand side of the periodic table. These are this is the right-hand side of the periodic table. So we want to explain group 1 and 2, and here group 7 and 8. 7 and 8. 7 and 8. So I want to summarize my lesson here. So thank you, my students.